Hi everyone, we will now do some examples for the indices that we've learned till now. So the positive, negative and fractional indices. Let's do some examples that you typically see in your exams and how we use the laws of indices that we have learned till now. Okay, so let's take this one. So someone tells me, give me this value, 64 to the power half minus 27 to the power 1/3. Right? How do we calculate that? What do we get the value of this as? Now, based on the fractional indices that we have learned, remember this is a negative sign in between, so you can't bring them all together till the time you've simplified them. So let's try and simplify them individually. 64, let's try and factorize it to the extent possible. 2 to the power 6 and this is 3 to the power 3, right? Now you can see where I am going. 2 to the power 6, this gets multiplied. Remember the multiplicative rule? So you multiply the powers that we have here. So 2 to the power 3 now, and this is 3 times 1 by 1/3 gets cancelled. So this is just 3 times 1. Simple now, 2 to the power 3 is 8 minus 3. So your answer is 5. It didn't look like something as simple when you were using that equation. So essentially we try to put these in terms of an index notation for things like this and simplify from there. Okay, now next problem I have seen is something like 25 to the power of minus 1 by 2. Okay, so it's fraction and it is negative, both in that. How do we deal with this? So we remember, if you have a negative power, something like this, you can take a reciprocal of the number itself. So it is 1 by 25 and you can take the positive power of that. Okay, so we've dealt with the negative power. So the negative power is now gone. It is a positive power, right? It's still fractional and we'll find out how to deal with that. But at this point, it is not negative. So we've gone and dealt with that. We are now trying to solve for this fractional power. Can I factorize this? Can I put this in an index notation? So 25 is 5 to the power 2, right? So 5 times 5 is 25, so I can write this as 5 squared. And then you have half there. Remember this rule? Very important. We can use that. 2 and half gets multiplied with each other, so you get 5 to the power 1. So essentially your answer is 1/5. Okay? A very, very important identity, or the usage of the identities that we've learned till now, is this. If you have 2 by 3 to the power minus 2. See, we said that this is negative power. How do you get negative power removed? You do the reciprocal. I said reciprocal always. We did not say that you just have to divide it by 1 or, take it 1 on that. Reciprocal is essentially you just reverse these things, because we did not have anything as a denominator here, right? Which means 1 was the denominator and we took the reciprocal and 1 went up. So in this case, what we will do is 3 by 2. What you have done, you've just reversed it. The reciprocal of 2 by 3 is 3 by 2. And the power becomes square now. This is very, very useful. I will in fact write it in this list of indices so that it is useful and ready for you when you want to use it. So I'll put it this way. As an extension of this, if you have a by b to the power minus m, you can use it as b by a to the power of m. And this is very, very important. This is very simple way of removing your negative index, because it's easier to work with positive indexes, especially if you have fraction or if you have a numerator and denominator. It's just reverse the numerator and denominator and you get this. So ultimately you can't simplify it any further. I think the answer is 9 by 4. Okay. Okay, so let's take something that is very common, 8 to the power minus 2 by 3. So whenever you have these things, we should have practiced it enough that it strikes us where we move from here. Okay, so maybe it may be easier if we have some of these basic indices memorized. So 2 to the power, especially the powers of 2. 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128, 2 to the power 8 is 256, 2 to the power 9 is 512, and 2 to the power 10 is 1024. Now you may not have to learn all of it, but because 2, 4 and 8, all of them are related to each other, so every time you have any of these numbers, you would know what to do, how to factorize them. And maybe also for 3 square is 9, 3 cube is 27, 3 to the power 4 is 81. Stop there. 4 you should know already, because 4 is this itself. 5 square is 25, 5 cube is 125. I think these are very basic things. We should just have that in mind, because any of these numbers, as soon as you see them, it should strike you. Because I see 8, I know it's a cube of 2, it should strike me that I have to write this like this. And then immediately you can see the benefit of writing it like that. You can cancel this 3 with this 3. So you're left with 2 to the power minus 2. We could have dealt with the negative index earlier, but we can do it now. So, and this is 1 by 4. So this is very important when we are solving the problems of index. Maybe keep this in mind, because a lot of these problems will require you to factorize in a manner that uses these numbers. Okay, and maybe for 6 and 7, extend it to 6 and 7. Maybe till 7 at least. The square of 7 is 49. We should remember. So as soon as you see a number 49, we should just write that, that has to be written as 7 square. And that's how we progress on things like this. Okay. So we'll take one more example of something similar and try and understand how do we solve things when you have problems like this. So 81. So 81 should strike us as something that's very clear. Minus 3 by 4. Okay, 81 to the power minus 3 by 4. Now remember, 81 we have said that should strike us as 3 to the power 4. And then you use minus 3 by 4 here. So 4 gets cancelled, 3 to the power minus 3. We do this, and this is 1 by 27. That's our answer. Okay, so it is important that we keep all of these formulas or identities in mind and remember them when we are applying it. Right? And there may be some tricky questions that we have to be careful of. So we haven't done the advanced volume of indices, and we will do it later, but when people are confident on this, we can go there. So let's take an example like this. This is more trick than anything else. If you have 7y to the power 0 squared. Remember, this y to the power 0 is just for y, not for the entire thing. Right? So this is, let's first solve this. Y to the power 0 is 1. So this is 7 times 1 squared. So 7 squared is 49. That's the answer. Now, if this was something like this, seven y to the power 0, or 7y squared to the power 0, then this answer would be 1. These are two different problems. Okay, we'll take some more examples. 8a cubed b, and you have to do a 1/3 of that. Okay, so what we can do is, see, 1/3 of this entire expression means we have to find 1/3 of each of these. So we'll try and expand this. This is 2 to the power 3, this is a to the power 3, and this is b to the power 1. We need a 1/3 of all of this. So 1/3 power, this has to be now multiplied with each quantity. Remember this rule? So when we multiply 3 and 1/3, it becomes 1. So it is 2 to the power 1 times, again same process, 3 into 1/3 is 1, a to the power 1, and b to the power 1/3. So your answer is 2a and 1/3 for b. Okay, you can also write this as 2a cube root of b. Okay, one more, 3x times 3. How do we write this? This is 3 to the power 1, so 3x to the power plus 1. That's all. We can't go any further. That's the answer. We'll take a few more examples before we finish this topic. Okay, so if you have something like 2 to the power x by 3 and square of that, simply you can't do much actually on this. 2 to the power, you have to multiply these two things, 2x by 3. That's the answer in this case. Okay, if this was 2 to the power x by 2 and you had square here, then you will be left with 2 power x. Okay, so I think we've taken some examples that we wanted to look at. We can continue with things like this, but I think it's more for everyone to now practice these sums out and send out any questions that you might have. Okay, so if I get this 3, 4, 3 to the power 2 by 3. So 3 to the power, this is actually 7 cube, and then you do 2 by 3. When you multiply this gets cancelled. 7 squared is 49. Right? Now these are some examples we wanted to cover. Please go through this. In the next session, we will talk about the scientific notation. Thank you.